Welcome. This is a session where we dive a bit deeper on all the announcements that Pete did, and we give you a bit of context and where are we going with our cloud native platform in general. You have the full ECM team today. You have Ollie in the background. You have Jeff. You have Jaren, and you have me. So you got basically the full engineering and product management team today. And this is quite interactive, so if you have questions, just raise your hand and we can have a conversation. So first of all, we wanted to start and highlight how much AI is driving growth in the whole cloud-native space. And meanwhile, it's really hard to find for on-prem deployment numbers. These are just the numbers for public cloud. And if you look at especially the growth numbers for only infrastructure as a service, right? Only this year, it's a growth of over 25%, and next year, over 30%. And this is only public cloud. And the main driver is AI. And when people want to run AI workloads, they want to run it on cloud-native platforms. The other major trend which is happening is that hardware and software, the lifecycle gets quite disaggregated. So we had today already on stage, for example, Viasat, which are running Kubernetes clusters and a cloud-native platform, for example, to power in-flight Wi-Fi, right? And on the right-hand side, you can see how car manufacturers and so on are providing software services, for example, in cars, right? And there's later as well a talk from Hyundai about their connected cars. The major point here is that you see a massive growth of cloud-native platforms. And what becomes very apparent is if a couple of years ago, the question was, do I run on public cloud, yes or no? Today, what we see is you have really a distributed cloud-native platform. So it's all about, yes, I run workloads on public cloud, right? I have, for example, a machine learning workload on a data batch, and I have get the data batch once per week. I spin up on demand in AWS a cluster, do the data job, and I tear it down again, right? I have, for example, a GPU workload, and we have customers that do this on the fabric floor to tune machinery in real time. Yes, that needs to run on the workshop floor, right? So it's all about that workloads need to be run where it makes most sense for you. And what we are seeing is that many, and you can see this in the latest survey from the CNCF, that it's not anymore about, do I go full on public cloud? Do I continue with on-prem? You do all of it. And this really informs what we do with Rancher. You can see then that this whole cloud-native trend is as well very apparent in our own open source tech, right? You can see that our key projects, for example, like K3S, they grow 60% year on year. As well, for example, we have over 50,000 active Rancher managers instances. Harvest as well has a massive growth, right? So you can see that the cloud-native trends become as well very apparent in our own open source software. And that's the other major trend. It becomes all legislations. They are basically looking more at software supply chains. And as well, this really matters for open source. And especially here, SUSE, and we have a lot of experience to build trusted supply chains for the whole software. And this really is the baseline, what we are trying to do with what we call Rancher Prime. So the first question is, what is actually Rancher Prime? And Rancher Prime is our whole cloud-native platform. And you have Rancher, it includes our distros, K3S and RK2, which is for most customers the most basic setup, right? But we have as well virtualization with Harvester, and we talked a bit about it. We have storage with Longhorn. We have security with New Vector. We have Elemental, which we talked, I think, with some of you yesterday, how you can manage basically directly with Elemental in a cloud-native way your operating system, which is in our case Sleep Micro. And we have our newest edition, Stack State, which provides you end-to-end observability. If you're wondering what we are offering in pure upstream versus our commercial offering, which is Rancher Prime, it looks a bit like this. So meanwhile, everything we do is open source, every artifact. We offer an enterprise lifecycle, and we go much deeper in a bit on this. We offer you secure and a trusted supply chain, which becomes much more important, especially how legislators are looking much more on regulations around your software supply chain. We have add-ons, and we're going to dive a bit deeper on application collection, which is one of the key add-ons we just introduced. And of course, we have support, and we collaborate with many customers in development. This is how the reality for most of our customers look like. They do all of this. They have a fleet of clusters where they have something in the public cloud, they have in the private cloud, and they run stuff on-prem. And who are our customers, or our users? Those are platform teams, right? And we give them, as our key mission, the tooling that they need to build a coherent cloud-native platform across this distributed platform. But this is the other truth, right? It's quite an old tweet, it's from 2017, but it still remains true. Most of our customers, or everybody, especially big organizations, they already have done investments, right? They use, for example, they have chosen GitHub, or you have chosen GitLab, or you have chosen a certain SSO provider like Okta or other things, right? And we need to leverage those investments. And as well, every organization, they have a different contract when it comes to what are the responsibilities between the platform team and the development team. So at Rancher, and what we are trying to do with our platform is give you the toolbox that your platform teams can build out basically the platform that makes sense for you. And this is how many customers are basically finally using us, right? So they use our UI as a self-service gateway for their developers, for their stakeholders, to provision the services that they need. And everything else you can even do already today with our toolkit in a very scalable and sustainable way. And that's the other key point nowadays, right? As you can see, you have this total explosion of containers and cloud-native technology. We need to help platform teams to scale and make those operations sustainable. And for example, one of the latest things we brought into Rancher to really support this is Cluster API, which supports much better declarative and sustainable cluster operations. And all this tooling really can help you to run a sustainable operation across your whole distributed platform with clusters you run on the edge, with clusters you run, for example, in the public cloud, and all with one self-service gateway. So this is basically the roundup what we really announce. And we have a new lifecycle, which is much closer aligned with Kubernetes Upstream. We have an LTS Prime and Core offering. We bring in virtual clusters, and we go a bit deeper in a bit. Observability with our friends from Stack State, application collection, and there are, of course, updates around New Vector, Harvester, Longhorn in our distros. So let's start with lifecycle. We are closely aligning our, and I think a picture says more than words, so closely aligning with Kubernetes upstream. And Kubernetes releases every 4 months. So in August, there's actually the next Kubernetes release. It's the 130 release. And we're going to release as well. And then in December, when there's the next Kubernetes release, we're going to do a Rancher release as well. And this gives you a very predictable and easy to understand release train. As well, it allows us to be closely tailing what is happening upstream. And what we do then is we give you an 18-month life cycle for every Rancher Prime version. And when we say Rancher Prime, we mean Rancher Manager plus the distros, and we are aiming to get by end of the year everything in our portfolio, in our cloud native platform, onto the same life cycle to make it very easy for you to understand. We offer then basically an additional 6 months as the LTS Prime, as a commercial offering for LTS support. And this gives you the option that every second version you can use for 24 months. Additionally to this, we are offering what we call LTS Core. And LTS Core is really targeting only our Kubernetes distributions, our K2 and K3S. And especially, as you have seen before, we see this massive proliferation of Kubernetes clusters running in embedded use cases like airplanes and other devices. We need to make sure that, or medical machines, right? We need to make sure that you get, through the whole lifespan of this machine, Kubernetes support, or for your platforms the support that you need. And this is why we're introducing an option where you can have for K2 and K3S an LTS offering, which is LTS Core, 3 to 5 years. Additionally, when you are a commercial customer of us, Prime, you get every single artifact via our own registry, which is a Prime registry. And this gives you access to a software bill of materials, which gives you a whole list of the ingredients that went into our software. And this ties back again to the whole regulation and compliance, because like this you can make sure that we did not infringe intellectual property of third parties, and it makes sure, for example, that you can be sure what dependencies and what versions went in, and see how, if there are any security vulnerabilities. It's not just that. So we are currently supporting Salsa level 1, which is an attestation that what went into our build process is the same thing that went out. And we want to have Salsa level 3 attestation by end of the year for our Prime, for our cloud native portfolio. And of course, our artifacts are signed by us, and which gives you a kind of an additional security layer. This is then zoomed in how the lifecycle looks like. So you can expect that LTS Prime, which gives you a total of 24 months, it's every second version. And we start, the first version that becomes this will be 2.9, which will be released in August. And LTS Core, which is only for our Kubernetes engine, the distros, it will be 1 version per year. Virtual clusters. Virtual clusters is as well into the same theme of platform engineering we talked a bit before. It's Kubernetes or tenancy is one of the key questions every platform team has, right? How can we guarantee that every team has the autonomy that they need to deploy what they need with the right level of isolation? And so far, you had basically 2 fundamental options. You could virtualize on your bare metal and have a cluster for each tenant or each team. And this has a downside that this is quite expensive, right? Because I need additional control planes, I need additional etcd, and basically you're replicating a lot of overhead when it comes to resource consumption. The other was that you could use the Kubernetes namespace concept, right? Because when it comes to Kubernetes, when Kubernetes thinks about tenancy, they use namespaces. But namespaces are much more like a flat share. So everybody gets a room, but you share the same kitchen, you share the same living room and the same bath, right? And this comes with its own set of problems. So virtual clusters give you a nice combination of both, right? So you get the autonomy and the freedom, like you have your own flat, but you still maintain the right level of isolation. So if you do a party in this flat, which is your own, you can be sure that, or hopefully your neighbors don't wake up. And the great thing is it's a very efficient use as well of the resources here that you have. You don't have the overhead of using additional control planes or additional cluster per tenant with everything. So this is currently in what we call our early access program, and our first version is available under the project name K3K, because our virtual cluster technology is based on K3S. And we can provide you a link, or you can just Google it, K3K. You can try it out and give us your feedback. The goal with virtual clusters is that by KubeCon Salt Lake City this year, we have a version that is fully GA and comes with everything that you need. So if you have feedback, please feel free to reach out. We are happy to consider this. And now I head over to observability.
Well, thanks, David. So when David asked me yesterday, hey, I'm doing this talk on ECM, roadmaps, I want you to do something on observability. I said, okay, what should I do, man? We were just acquired. I can't talk about the roadmap yet because I don't know. But I at least can talk about what observability is according to stack state. So, well, observability, it's the ability to measure the internal state of a system by examining its outputs. So, be able to tell what's happening, what's going wrong. You do that basically to understand health and performance. Is my application healthy? Is it performing as it should be? You do that for proactive monitoring and incident response. You want the people on call to be alerted in time so that they can actually respond, fix the issue. And proactive monitoring, you want to be able to look at the application, see what's happening, and maybe optimize, right? So in the end, it's about reliability and performance optimization. Observability's goal is reliability, ensuring that your applications, your critical enterprise infrastructure is running as it should be. So, and according to stack state, observability is not only about collecting data, it's about gaining actionable insights. Know what to do, when to do it, and where to find it. So for this, we typically have the 3 pillars of observability. Everyone knows these, right? You've got your metrics, numerical measurements, health, performance, latency, throughput, CPU usage, memory usage. You got your logs, basically the oldest form of observability. I came from a time when I was writing Java applications, and in order to know what was happening, I needed to write a log line saying, okay, this request took so long, I saw these and these parameters coming in. Logs, basically the foundation of observability. What occurred in your system, which lines were hit. And then traces. Traces actually show you a detailed record of how that user actually traversed through your application. And with these 3 things, basically when you collect them, you put them into an observability system, you get something like this. Anyone knows this? A dashboard? Who uses this on his day-to-day basis? Some hands? I expect some hands at least there, yeah. So it looks nice, right? Is this observability? Anyone? Well, it shows you all of the signals, in this case for a service, all the SRE golden signals, error rates, request throughput, latencies. It looks pretty fine. But you need a bit more for observability because you need to add alerting to it. You don't want to spend your day, every day, looking at that dashboard. You have the network operation control rooms where people have these big dashboards day to day, but they cost a lot of money. So you want to add alerting. So for your metrics, for instance, when the average CPU utilization for a pod goes over 90% for a 5-minute period, set an alert. Pod could be in trouble. Well, for your logs, well, if there are more than 15 failed login attempts detected in the authentication service within a 5-minute period, it could be a security incident, could be a DDoS, could be somebody trying to break in, or he forgot his password. And alert if traces from any service contain spans with status codes 500 or 503, basically internal server errors, users seeing errors happening in the system that are not handled correctly. Is that observability? Well, actually, does it help you troubleshoot? When you have these alerts and that dashboard, can you actually see what's going wrong and what caused it? Can you answer why are the error rates spiking on that dashboard? Can you find what is the impact of the outage of this service? Which other services are actually affected by it? Can you answer why is my service getting 20% less traffic than yesterday? I want to see it over time. And how did the deployment of that new microservice actually affect overall system performance? These are the questions that you actually need to answer with observability. It's not only, is it down, but what caused the downtime? Where to find it? What caused my performance problems? Where to find those? So the way to do that is actually by first adding more data. You need more than just those metrics, logs, and traces. You need to know changes. You need to know events that happen throughout your system. Kubernetes, Rancher generates tons of events due to, in the total life cycle. You need those. You need the metadata of all of those things to answer the what and where. And in the end, you need to know how is the world related. What is talking to what is owned by what. So it's not only hierarchical relations like you have in Kubernetes, that a deployment spins up a replica set, spins up a number of pods. A service actually is fronting a number of pods, but you also need to know what is talking to what. Which pod, which process are actually connected on the network level. And when you do that, you actually get stack state. You get the dependency map that Peter was talking about in the keynote this morning. You see a fully built picture of an application that's running and that might be in trouble. Stoplight colors, orange, there's probably a performance problem going on right as we're looking at this. And then all of those signals, when you correlate them, like we do, you get this nice dashboard, still a dashboard, but this dashboard is correlated over time over all of these different signals that we've added to that set. You see Kubernetes metadata, events, metrics, etc. And why is this important? Because when we looked at that first dashboard, all of the correlation had to happen within the head of a developer or of an engineer. The guy looking at the dashboard needed to connect the dots. With stack state, actually, that's no longer necessary. How can we prove that? Well, I grabbed this screenshot and I uploaded it into an AI. I asked, okay, you're a Kubernetes troubleshooter, please tell me what's wrong with this service. And actually, it gave me the correct answer. So by correlating the data, by adding all of that context in stack state, actually even an AI is capable of doing troubleshooting, meaning that all engineers should also be able to do this, which is not possible with the simple dashboard. In this case, it was a configuration change was noted at 0905, specifically a deployment, which could be directly linked to the issue observed. Well, it got that right. That deployment actually caused this service to start malfunctioning. So for stack state, that is what observability is. That is what we are offering into the Rancher Prime ecosystem starting from 3.1. Thank you. David, back to you. Yes? StackState actually offers a SaaS for Rancher community users from very soon onwards. And for Rancher Prime, Rancher Enterprise users, it's possible to run this both on-premise and fully air-gapped, yes. So in Rancher Prime, the goal is whatever Rancher manages, you can observe. Moving up to Rancher Enterprise, it's actually possible to also add legacy application data to StackState, or to Rancher Observability, whatever the name will be. We don't know yet. David?
All right. So you can see as well how observability fits into the bigger picture here of much more complex environments managed through a single pane of glass, and how we can support you here. Another very important addition we did is our application collection. And this is available for every single Rancher Prime subscriber already today. So if you're already a subscriber of Rancher Prime, please feel free to reach out, because you can use this today. What is it? What is often happening, and it became, I think, as well apparent in the beginning, is a platform is much more than just Kubernetes. You need additional components, for example, like Apache RP6, right? And what happens is that your developers or other teams, they just will go to the internet and they will hit Google and they will install the first thing they can find. And often this comes with a lot of CVEs, a lot of dependencies, right? And this is a real-world example, right? And you can see how a lot of the CVEs, they come in from the base image they're using. For example, you can see they built Apache RP6 3.8 on Debian, right? On a free available Linux version. What we did is, and we have a lot of experience in this as SUSE, right? Building software in a reliable way. We created application collection, which is a set of curated open source software, for example, like Apache RP6, and we use our own base images, our own build process. We build it from the ground up again. And this gives you basically this. A version of Apache RP6 which has 0 vulnerabilities. Because we use, as a Linux vendor, right, we maintain our own Linux kernel. We maintain a lot of our own base images. And this gives us the capabilities that we can make a very clean build and a very actual build. And it comes with everything you need with Salsa Level 3. It comes with the SBOM. It comes with continuous vulnerability scans, and we're using, of course, NewVector and Trivi and an antivirus scan. The other magic is if a new release comes upstream, we are watching what is happening, right, all the time. And in a couple of hours, this will be made available via the application collection. So our build process is all the time watching what is happening. And if we detect something, our build pipeline kicks off and we make it available for you. We have currently, I think, over 27 applications. Those are some stats since we introduced it in March 24. We have already a lot of enterprise users. If you have an application, how to find it first? You go, what is the URL of application collection? I think. Thank you, Jeff. It's apps.rancher.io. Feel free to go to the website. The application list you can see already. You can use your SCC login if you have one. And if there's an application missing, we are happy to work with you and the application team to get it into our application collection. Again, this is a bit the theme, how we help you to build out platform that is trusted and compliant. So what is coming next as big applications? So we're going to introduce Harbor. We're going to introduce, and this was already announced by Pete, Kubeflow, and we're going to introduce Grafana. NewVector. NewVector is, as if you don't know, our security suite for the cloud-native space, our cloud-native platform. And the newest things is that we built a UI extension. So now you get NewVector directly in the Rancher UI. And I think we have this little slide here, which shows you how it will look. This is going to be released in Rancher 2.9. And it helps to continue the journey to move security concerns much further left, right? Because, for example, your platform teams and your developers, they use software like Rancher. And when they, for example, deploy their images to staging or test, right, they can see directly the scan results in Rancher. So this is really big. So if you want to try already the UI extension, feel free to reach out. We are happy to make it available for you as an early access. The other thing we introduced is the real-time compliance reports. And for example, there are frameworks like Stick, right? And if there's happening an update, even in the compliance framework itself, we will in real time almost check again what is happening with your deployments and give you the reports and data that you need. Denial of service attacks, Pete talked about it. So we introduced much better detection if there's a denial of service attack going on, and then we can basically take remediation steps and block them out, and of course notify you about it. So that's a bit the fuller picture where we want to go with NewVector. And it's basically, the whole idea is that we shift security much further left, right? Instead of having security as a concern at the very end of a security team, we want to have it as part of your developer story, as part of your platform story. I think Harvester, you had already as well quite some updates. So Pete already mentioned how great it is as a tool to bridge the gap between cloud native and legacy. You can use it in two ways, right? One is you can, if you want, virtualize your bare metal. If you are, for example, looking for a tendency strategy where each of your teams should get its own cluster. And the other thing is you can do with it, you can directly run legacy workloads, right, or VM workloads in a more cloud native way. The new thing which went into it, and this is now a bit repetitive because we already had it in the keynote, so I will quickly go over it. We are now supporting vGPUs. We are now supporting ARM. We are much better when it comes to high availability, so we support 2-node clusters. And what we're going to do in future, we want to support more storage options, we want to have more validation, cluster rebalancing, enhanced backup and DR story, and broader support of third-party backup software. Longhorn as well, our storage play, and you can see that even the Longhorn adoption is massively growing. There are over 125,000 Longhorn nodes out there. And the significant thing we're really working on is the new data engine. If you're using Longhorn, you might know that one of probably the things which most hold you back in going fully in with Longhorn is the performance. So this is currently in technical preview, and by end of the year, there should be the new data engine fully rolled out, which should give you the performance that you would expect from your storage system. And now we're getting to our Kubernetes engines, RK2, K3S. As well, GPU support is front and center for us. So we have a lot of customers that already run AI workloads, and we fully support the NVIDIA operator, which gives you the capability to run GPUs on, or basically GPU workloads on K3S and RK2. Scale is as well important, and this is why we brought in an embedded registry, which is Bagel, into K3S, and what it does is it's basically caching the images that get into your cluster. So instead that every node reaches out on their own to get the image, it gets once into the cluster, and then it's cached and distributed from there. And especially as well in edge environments, this can have massive improvements because it has a massive improvement on the network and a massive improvement, overall when it comes to resource efficiency. Besides this, ARM64 support is coming in RK2, and of course, right, we are always quite close with Kubernetes upstream, so 129 support, but that's business as usual. Good. Finally, it's as well a bit older, but I wanted it to mention again. What we are doing in Rancher Manager itself, we are bringing all important functionalities onto the Kubernetes API standard, which is basically having a custom resource definition, and this gives you then the capability to have a custom resource and directly use GitOps kind of flows to automate your flows. In Rancher Manager, for example, you want to manage projects in a GitOps way, you can do this already today. And we're going to continue to move Rancher functionality onto the Kubernetes API standard model, which is basically having everything defined as a CRD. Now we are coming more into our future-looking statements for this year. And I think we talked about it, right? So multi-tenancy is front and center in our thinking with virtual clusters. The project name today is K3K. We are working very hard this year to make our platform the best, your platform of choice to run AI workloads through the whole stack, right? And it starts on our distros with GPU operator support. You can see it in Harvester with virtual GPU support. You can see it with supporting or making available Kubeflow for you in application collection. Then you could hear our colleagues from BCL, which are working really hard on confidential compute, which becomes as well much more important when we are talking about processing a lot of data. So you're going to see how we make sure that the attestations that come from the hardware memory level for the encryption, we pass through to the whole container to make sure that you can run confidential containers. As well, very important is becoming what we see as an serverless evolution, which is basically WebAssembly. And we already support the WebAssembly shim in K3S and RK2. And this gives you the capability to run directly WebAssembly functions in Kubernetes. And why is WebAssembly so important? When old or traditional serverless models often had quite a significant cold start time. With WebAssembly, this is basically a concern of the past, and it's directly there. Observability, the future already caught up with us, and we could accelerate this significantly with our friends from StackState or SUSE StackState. And I think what we are looking next into it is how we can use better insights into the platform in general and give you more information around costs and under-subscription, over-subscription of resources to make basically, when it comes to your cost management, a very efficient resource usage. And that's our roadmap. Okay, then we finished just 1 minute before end of time. So.